Howdy. Good morning. Aussie, Aussie, Aussie. Okay, there are some people here. I'm extremely honored and pleased to be with you. It's my first time to Australia, and so far it's been awesome. I'm excited to meet all of y'all and to learn with you and learn from you this week. Quick shout out to the organizing team. We're like 2 hours in, and I'm already just convinced that this is the most thoughtfully organized and prepared conference that I've ever been a part of. So Ben, Glenn, Carolina, Craig, Jordan, Michael, everybody, all the volunteers, let's clap it up for them, because this is... Y'all have done very well by your community, and I'm grateful that you had me here. I am Michael Rog. This is my email address. This is the website where after the talk I will put all of the resources and citations and further reading links. I do hail from Texas, the land of bluebonnets and barbecue, where all the web developers have cowboy boots and ride our horses to work. When I'm not crafting code, I like crafting cocktails and fancy food, and I like to swing dance, and I work out with the local circus, and I tell you all of this so that if you think the talk bombs, you'll still have a reason to be my friend in the coffee break. But please do check out this website, and my heart is broken because we have no QA today, but I love questions, so please, if you have questions and thoughts about this stuff, get in touch with me. I would love to hear from you. So we're going to talk about accelerated mobile pages, and when I think fast, I think the BE-4 rocket. It's the first rocket ever to take a spacecraft up into space and back down, setting it gently back on the ground, right side up. That's from Blue Origin. A good friend of mine works there, and when I think fast, that's what I think. I think I want the mobile web to be rocket fast. But before we talk about accelerated mobile pages, we need to address the underlying human motivation for why we care about making things fast, and that is that attention is the single greatest resource that we can possibly ask of someone. Attention, I define attention as intent applied over time, time being really, really valuable, as we all know. And because time is valuable, we need the content that we produce, the experiences that we produce on the web to be fast, especially on mobile clients, in situations where the device might not be as powerful or the network is not as fast, such as some of the stories that you heard earlier from Ali. The mobile web is really a sensitive area for performance, but it's also very important. 1 in 4 Americans only browses the web through their mobile device, and this, as you've heard, is greater in other parts of the world. And so we need content on the web to be really, really fast. So picture yourself for a moment. Everybody, close your eyes for a second. Picture yourself in your imagination in some place where your time is very valuable to you. You're at a bus stop, you're in between meetings, maybe you have definitely not pulled out your phone at a red light, but somewhere where you have only a little bit of time. And someone that you like has posted a cool-looking story to that social app that you use, and you think you'll check it out, so you give it a click, and you wait. And you wait. After a few seconds, the little progress bar at the top of your mobile browser is starting to make moves, so you have a little bit of hope. The background maybe changes color. Progress bar inching forward, and hark, some text appears, but it's kind of tiny. You can't read it. Your phone might be moving around. Maybe you're walking. But you're starting to read this text. You're determined. All of a sudden, the text disappears. But a second later, it reappears. It's a little bit bigger now and in a different font, and so you've lost your place. But again, you're determined, so you're still reading. It flickers again, and then some images start to appear. And with every image that appears, the text on the screen gets jostled around, but you're still trying to read. You're determined. And then an ad appears. And not just any ad, but a full viewport, interstitial ad. You know it's an ad, not because you can see the ad. That hasn't loaded yet, but you see the word sponsored content at the top of this blank white box, right? And you're a web developer. You know where this is going. The ad script is going to load an analytics script. It's going to load a beacon script. It's going to load a platform script. It's going to load another analytics script. It's going to load another beacon script. 50 scripts later, this is never going to load. And so you do the only reasonable thing, which is, in a fit of rage, you open your task manager and you swipe your browser into oblivion. And you feel defeated. Raise your hand if this situation applies to you on a regular basis. Open your eyes for the grand reveal. Now, hands up. This is a problem. It's a big problem. After 3 seconds, Google tells us 40% of your traffic drops off. After 10 seconds, you've lost everyone. You've lost 100% of your traffic, which is ironic because the vast majority of web pages take more than 10 seconds to load on a lot of mobile browsers. Swaths of the internet are not being seen at all for lack of resources and lack of patience. And in between these two data points is just a spectrum of pain and anguish, because we know that engagement is proportional to speed. The faster our thing is, the more engagement we're going to have. And so when somebody isn't getting your content, it's a lose-lose-lose. The publisher's going to lose, right? They can't get their content to their viewers, but they're also missing out on the user acquisition advantages and the monetization of that content. Platforms lose because a bad experience with an embedded page or an embedded experience spills over and causes bad perception in a UX sense of the overall app or the overall platform. So platforms are losing, but most of all, the user is losing. They're frustrated. At best, they hate you, right? And at worst, they hate you, and whatever you have asked their attention for, they didn't get. They feel defeated and discouraged. So at the heart of it, this isn't really going to be an accelerated mobile pages talk. At the heart of it, this is actually a web performance talk. AMP is merely the vehicle. It's the framework that we're going to use to talk about web performance because it gives us a lot of cool web performance out of the box and sets a lot of good examples for us. And that's why AMP is relevant and why you should be paying attention to this project. But at the end of the day, we care more about making things fast than we do about AMP specifically. And so as you're listening to this talk, I want you to get interested in AMP, but I also hope that we'll take some pointers from AMP that we can apply to the web at large. So we start with this 3-point premise. First, the mobile web depends on performance. Good performance means good experiences on the mobile web. We also have pretty good best practices for making things fast, and they're getting better every day. We know how to make the web fast. And therefore, since we know that speed is important and we know that we can have speed, we have the technology to have the speed, then we also need systems for validating when things are fast and incentivizing developers, platforms, publishers, everybody to get on board and make the web fast. How fast? Well, Google tells us we really ought to shoot to deliver and render above-the-fold content in under a second. Now I know what you're thinking. You're thinking, how possibly can I deliver and render an experience in under a second? On a mobile page, the vast majority of the world still depends on 3G. Your best case round trip on 3G is about 200 milliseconds. That's a fifth of a second for the DNS lookup. It's a fifth of a second for the TCP connection. It's a fifth of a second for the HTTP request, right? That's just the network side stuff. Then you're going to spend, if your server can kick back a response in a fifth of a second, that's great, and that leaves you 200 milliseconds to render everything in an already compromised mobile phone browser. So this is going to be challenging. This bit, the network side stuff, we can't talk about too much today, but the server response and the client-side rendering, that's where AMP is really going to help us out. And so cue the angelic music. Google's answer to this is accelerated mobile pages. Accelerated mobile pages is Google's answer to this premise that we should have systems for validating and incentivizing a fast mobile web experience. So AMP is an open source project. It's a proof of concept. It's just over a year old as an open source project, and it's backed by some platforms and publishers that you may have heard of, like Google and Twitter and WordPress and BBC and others. It forces us to use good best practices, stuff that you may have heard of, and if not, we're going to put it on your radar today. Stuff like inline CSS and GPU acceleration and efficient font loading, prioritized resource loading. And it does all these things in order to guarantee that our pages meet a baseline level of performance. And then, underneath that, Google's going to give us some extra machinery for caching and pre-rendering and discovering that fast content so that we can prefer that content and do cool UX stuff with it. So AMP is a tech spec. It's a tool set that we should take a look at. But it's also a business opportunity for board members and product managers and anyone who asks you, hey, developer, I need one more analytics script on our page, right? This is your answer to them to say, no, we shouldn't clunk up our pages with all of this stuff. There is a better way, and that better way gives us advantages in a business sense, in a user acquisition sense, in a monetization sense, so that we don't get caught fighting things like user acquisition with things like web performance. And also, as I've said, it's a learning platform. It sets a lot of good examples. It forces us into bad habits, but it's also a study case that we can look at and take some concepts out to use, whether or not we are going to subscribe to the AMP spec specifically or completely. Whether we want to, whether we're able to, whether we care, there's still some good examples to be learned. So let's take a look at the parts of AMP. AMP has three major components. There's the AMP HTML, the AMP JS, and the AMP cache. The AMP HTML is the set of HTML elements, native elements, and some custom elements that form the spec. And just like you can validate HTML, you can validate CSS, you can validate anything that has a spec, you can validate AMP. So to validate AMP means that you are using the stuff that AMP says you can use and not using the stuff that AMP says you can't use. And so it's just plain Jane HTML with a little bit of sugar. Then we've got the AMP JS, and this is the JavaScript library that you'll include that will sort of validate and enforce the spec, but also bring it to life, instantiate all these components, and supercharge your AMP HTML. And then we've got the AMP cache, which is going to do some network-side stuff for us. So again, we're addressing the latter part of this crucial, valuable 1 second in which we're rendering stuff. We want fast server-side response, and then we want fast client-side rendering. So we'll first look at the AMP HTML. It looks, to write an AMP HTML document is no great feat. It looks like regular HTML that you're used to seeing. It's got the HTML doc type there up at the top. It's got a special attribute on the HTML tag, the AMP attribute, or if you're feeling frisky, you can use the lightning bolt emoji, and that's not a joke. You can actually use the lightning bolt in your HTML code. You've got to be using UTF-8 encoding because it's fast and it's consistent, and you don't need me to tell you that because you're already using UTF-8 everywhere. You need a canonical link because in some cases you will have your normal web page, and then you'll have the AMP version of that web page, and so you need a canonical reference back to the primary page, whether or not the AMP page is canonical. You need that link in there. And then, of course, we're including the AMP JS from the CDN. So we're including it from Google. It's very fast. And this will be the only script that is on your page, is the AMP script. Some structured data that takes the form of a script, like your JSON LD, is allowed, but you're not going to have any user-authored scripts. Then you'll have your styles, and you start off with the AMP boilerplate styles. And this is kind of in flux. It's subject to change a little bit, but right now the purpose of it is to help prevent that flash of unstyled content. So it's waiting on the JS to say, this page is ready, and then it's nicely revealing that page to the user, and of course there's no script fallback for that. And then we have your custom styles, and this is where you get to write your CSS, and you can write just about anything. You have to use simple selectors, but you can write your custom styles. And then, of course, you have your body, and in the body, you have most of your normal, content, your paragraphs, your lists, your headings. But you have some custom elements that AMP has substituted in for some HTML elements. For example, in place of a regular image tag, you'll have an AMP image tag. And the reason that AMP does this is so that the JS can have better control over the rendering process. So there's some cases where you'll just use an AMP element in place of your normal vanilla element, but of course it is still just HTML. And so then we animate this, we bring it to life with the AMP JS. The AMP JS is going to enforce that spec. It's going to keep us using those good practices. It'll also provide some dev tools. So if you have an AMP page and you tack on development equals 1 to the URL, then you get nice logging out to your browser console. It's pretty cool. And then the AMP JS does the magic. So what magic does it do? Well, async everywhere, that's very important. It makes sure that all the scripts and anything that gets loaded on that page happens asynchronously so that it can't clog up the render chain. It's also going to handle some DNS pre-connecting for you. So if AMP sees a component like, say, a Twitter embed or a SoundCloud embed, where it knows that something is going to need to eventually be loaded from a third party, it can prefetch that DNS so that you don't have to do that right when the user is trying to interact with that content. It speeds up the network interactions a little bit for you. It provides a static layout engine, which means that because in your AMP you will have, in your AMP HTML, you will have provided the specific widths and heights and aspect ratios of all of your elements, the layout is going to be independent from any media or content that needs to get loaded. That means that this layout can be determined only from the HTML, and it's immediately ready when the HTML loads the page. You don't actually have to load anything from a third party in order for that page to be ready for a customer to look at. So that's pretty cool. And then it also does some content prioritization stuff, which means it's going to take a look at where elements are on the page and what the user intent for those elements might be, and prioritize loading the content that a user needs to see or interact with first. So there are some limitations that are imposed by this spec. Like I said, you can't use any user-authored JavaScript. There are some ways around that if you're sitting here thinking, oh, but I want to start with an AMP page and then spin it up into a mobile web app, a progressive web app. Yes, you can do that, but that's for another talk. In a plain Jane AMP page, no user-authored JavaScript. And you have to use some custom tags in place of some normal tags, things like images or media, video, audio, stuff like that, to keep those elements subservient to the AMP.js rendering process. You do have to provide the fixed dimensions of your media, which you should be doing anyway, but that ensures that no third-party components, nothing needs to be loaded in order for that layout that static layout to render. And there are style sheet requirements. You only get 50 KB of styles, which is probably plenty enough to render a simple page on a mobile browser, and you have to use simple styles, so no star selector, because the performance characteristics aren't as predictable. So there are some limitations. That's the bad news, but the good news is it's guaranteed to be very, 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 very fast. And those custom components that we talked about aren't actually that limiting. There's a whole library. There's probably hundreds of them at this point, from every kind of media that you can imagine: images, videos, audio, stuff like analytics or ad blocks. So you can monetize AMP content, which is actually great because it will convert better for you on those monetizations because it's fast and the ads aren't getting in the way of the user experience. Interactive elements like carousels and accordions and lightboxes and user notifications and third-party embeds like tweets and audio and YouTube videos and stuff like that. So lots and lots of components. I don't think you'll find yourself limited if you start playing around with AMP components. And of course, the dev tools. So if you add that development =1 onto your URL, then you get a nice validator checklist and some informational messages in the browser console to help you as you go along. And then, to top it all off, we have the AMP cache. And I won't talk too much about the AMP cache today, but it's a proxy cache for AMP content. It's from this internet company that you may have heard of that is known for doing big, fast things. So the fact that it's backed by Google is quite a powerful statement. It means that CDN is pretty much everywhere. So going to be very reliable, very fast, and it works because AMP validates. So the AMP cache can be very reliable and very fast because you know, because of the AMP spec, that the AMP HTML is the only thing that has to load in order for that page to get rendered. You know that nothing is going to break by running this page through a CDN. And what that means is that when you're spinning up a page in a context where URL isn't really important, like in an iframe or in the web view of an app, like Twitter, you've clicked a link and you open up some web Chrome. Anywhere that a URL being pretty isn't so important, you can load that page from the CDN, and then you can leverage a lot of pre-caching and pre-rendering and pre-fetching stuff that AMP gives you for free. And that is going to enable the incentives that we talked about. Because we know that we can discover and access content that is guaranteed to be fast, we can create special experiences around that content, which incentivizes people to use it. So those are the three pieces of AMP. And if you wanted to see what it looks like in practice, you could actually do something as simple as a Google search on your phone for something maybe newsworthy. And when you search, you'll see this kind of carousel of news stories that pops up at the top, and they have the little AMP logo on them. And when you click them, they come up instantaneously. It's amazing. And not only does the first page load instantaneously, but you can swipe through that carousel and see all of the pages that were in that top stories carousel, and they all load pretty much immediately, which is pretty impressive. So how does this work? How are we able to achieve that kind of immediate loading performance? So here's where we're going to talk about some of the underlying design decisions behind AMP. And we're going to talk about how this makes AMP fast, but also, again, in the back of your head, I want you to be thinking, how can I take these examples and these best practices and make use of them whether I care about AMP or not? So we'll start with efficient font loading. So, the normal browser of your typical, the normal browser behavior on a typical page is you're going to download all the styles and apply all the styles and download all the scripts and run all the scripts, and maybe the scripts download some more files. And so after all of the styles have been applied, then the page is rendered. And at the first moment where a web font could be used because the page is being rendered, that's when that web font gets downloaded. So very, very frequently, we have a lot of assets in the critical path to rendering something like a web font. So AMP keeps that critical path clear, and it does that by asyncing all the scripts and by forcing us to use inline styles. And it makes sure that media gets loaded, pictures and videos gets loaded later in the render process than a web font that I need for above-the-fold content. So this is a bonus not only to actual performance, but to perceived performance, because the user isn't seeing those jitters and flickers. They just get a nice page presented to them relatively instantaneously. And so in AMP, you get this for free, but if you can't or don't want to be subscribing to the AMP standard, you can still defer and discard unneeded styles for later. Also, the inline CSS makes a big difference. So in AMP, you have this 50 KB block of styles that you can add to a page, which should be plenty. But maybe you're not using AMP. Maybe you're just designing a responsive web page. Well, you don't necessarily want to inline all your styles because we do want the HTML file to be reasonable and manageable and download quickly. But we want to prioritize rendering above the fold content. And so for any styles that are important, we want those to come across the wire probably with the HTML so that they can be rendered very quickly when the HTML file is downloaded. So there are some tools out there to help you do this. Anybody heard of Critical CSS? So Critical is this nifty tool. It's a command line tool, but it runs in Gulp and Grunt and all of your task runners. And it'll actually, it's super cool. It spins up your page in a phantom browser, renders the page, figures out what is going to be above the fold, pulls out all the style rules that are necessary for rendering that stuff, and generates you a little CSS snippet that you can inline with an HTML file. Then you can defer all the rest of the styles to the very, very end of the render process using something like load CSS. The static layout also plays largely into making AMP fast. The fact that AMP knows the dimensions of a thing without needing to load whatever media or component is going into that block makes it very, very quick for that first render. So you have to provide in AMP the width and height of your blocks. Responsive elements are okay too. There's an attribute that takes that width and height and assumes that it's going to be responsive but keeps the aspect ratio. And so you're locked into that size until a user expresses intent. And then once a user interacts with a thing, then you can allow that component to resize itself or scroll or whatever. And so you can be doing that too. If you're not already passing sizes of your embeds and your images, that's a thing to consider doing because it's really going to speed up that very first impression render that you get. Content prioritization is a thing that in AMP you get for free, just like above the fold. Styles are important. so too, above the fold media is more important. An image that occurs several scrolls down the page doesn't need to come over the wire before components and media that are going to be interacted with before that. And so again, in AMP, you get this for free. AMP takes charge of the whole rendering process and decides when certain media gets downloaded. But if you're not using AMP, you too can use your own component loaders, your own image loaders, your own methods of instead of lazy loading things when you need them, and that'll and that will improve again the rendering process to keep your experience fast. Okay, so DOM mutation batching. This is kind of technical, but I think it's really cool, and AMP does it again. In AMP, you get it for free. The general gist is that every time you access the DOM, the browser is having to apply styles and paint things. And so when we're doing our CSS animations and transitions and effects, we want them to be happening at that silky smooth 60 frames a second. But every time, in the course of our normal JavaScripting, maybe we're reading and writing to the DOM, and we're doing it in no particular order. Maybe we have lots of components on the page, or lots of developers or services doing different stuff, right? And so we're mixing our DOM reads and our DOM writes, and that means we're having multiple paints in every frame, right? And the more paints we have in the frame, an animation frame, the more work the browser has to do, and eventually the browser says, I can't take it anymore, I've given it all she's got. And then, the browser starts decreasing your frame rate, and so you get those janky animations, and we don't want that. It would really be great if we could batch together all of our DOM reads and all of our DOM writes so that we're only painting once per frame. You get that for free in AMP, but if you're not necessarily using AMP, there are other tools like FastDOM, which is from Paul Irish and some of the other Google guys. Definitely look into FastDOM. That'll help you manage when you're reading and writing to the DOM to keep everything fast. You can consolidate analytics. This is a really cool aspect of AMP because AMP gives you components for different analytics packages. And the way that works is when you're doing analytics on your page, your Google Analytics snippet is basically just taking some properties of your page and then sending them off to some beacon URL somewhere. And so we really don't need 50 different scripts to be sending analytics to 50 different services. Not that you should have 50 different services, but what AMP does is it consolidates all of that so that you can measure all that stuff once and then report it to several different services in a very efficient way. And if you're not using AMP, you too can kind of build your little analytics switchboard to take care of that if having a bunch of analytics and beacons on a page is a problem that affects you. And lastly, we've got a bunch of pre-connecting and pre-fetching and pre-rendering stuff. AMP automates a lot of this for free for you. Pre-rendering means to render content before a user actually arrives at that content. You get it for free with AMP, but if you're not using AMP, there are other ways to pre-render stuff. I should mention, AMP does this really cool thing where, if it's going to pre-render a page, again, because it sees the HTML and it knows what's on that page and knows how to lay out that page, it knows that it doesn't necessarily need to download every piece of media to re-render that thing in the background. That might be important. And so it'll put placeholders in place of some complex elements, and you can see what that looks like if you want to debug it with this special little hash on the URL. But you too, in your own pages and apps, can be utilizing this same sort of action. There's the link rel method of allowing the browser to pre-connect and pre-render and pre-fetch some stuff. That does have a downside, of course, privacy, because you might be asking a browser to trigger a view on a page the person hasn't actually viewed. It also can occupy a bunch of CPU and memory because we're doing it in the background, and if data is expensive, then we don't want to be using the user's bandwidth until they have actually interacted with the thing. But we can use the page visibility API to tell whether a page is actually active or whether it's being pre-rendered in a hidden frame. And remember, content prioritization is really important. Pre-render the stuff that a user is most likely to see. So I'm going to wrap up. These are the reasons that AMP is very fast. And there's more of them, and I encourage you to dial up that GitHub page, read the documentation, really get into this stuff. You get all of it for free with AMP, but they're great practices and examples that you can be using in all your stuff. So to wrap up, you're probably asking yourself, okay, this is all cool, but why AMP? Why AMP instead of just paying attention to web performance, right? And that's a great question. And of course, AMP isn't Google's only answer to the web performance issue. You know page speed insights. You know that even is maybe a minor ranking for relevance in some search engines, right? But you're thinking the great Wallaby race of the internet, right? Raise your hand if you've played Wallaby. Oh, I'm so disappointed. In the great Wallaby race of the internet, the hand-tuned site is always going to be faster. If you are doing all of this stuff yourself on your pages, it's going to win, right? But AMP is always going to come in just a very close second. And the fact that you get all of that for free makes it very compelling. It's a thing that you can use now, and like I showed you, being able to validate and guarantee that content is fast also does have platform benefits because you can build these experiences around them, and it has a business case, right? Because you as a developer are then empowered to show that there is a business bottom line advantage to conforming to this spec. So I hope that I've convinced you that it's a spec that you ought to look into. It's a tool that you ought to add to your tool belt. I hope that I've convinced you that it will empower you as a developer to talk to your product managers to make a good case for web performance, and I hope I've convinced you that even if you are not specifically using the AMP standard, the AMP spec, it is still a great set of best practices for you to explore and learn. Thank you very much for your time. I look forward to talking to you in the break, and again, please let me know if you have any questions or thoughts. I can't wait to meet you.